In this exercise, we're going to draw line segments, and we're going to measure the angle made by these line segments using the protractor. Okay? So the first thing we will do is to draw our line segments. First we draw a horizontal line like this. You can call that the x-axis, and then the next line is going to intersect at some point along the x-axis here. Intersection. So now we want to find the angle made by these two lines that I have drawn, and so we'll use the protractor to measure the angle made by these two lines. So first thing, I will take the protractor and I will set it at the apex where the two lines meet, and then I will measure counterclockwise from the 0-degree line of the protractor to find the angle made by these two lines. So I go this way, 30, 40, 45, 50, and it says here the angle made by these two lines is 53 degrees. 53 degrees. So we got that measurement by using the protractor. Let's do another example. So I will take my ruler, make a horizontal line representing the x-axis. And then I will make the second line also draw that line so that it intersects with the x-axis at that point there. So now the angle made by these two lines, if I measure counterclockwise, would be this. So I need to find the angle made by these two lines. So once again, I will take my protractor. I will set the protractor with the crosshairs at the apex where these two lines meet. And then I will measure counterclockwise once again. I go through 10, 20, 30, 40, 50, 60, 70, 80, 90, and I still keep going. 90, 100, 110, 120. So the readout on the protractor says the angle made by these two lines is 120 degrees. Okay? So that is how you use a protractor to measure the angle made by two lines drawn on your diagram. In this exercise, we are going to identify and name 3 different types of triangles. The first one is called a right triangle. The definition of a right triangle is that one of the angles will make a measurement of 90 degrees. Therefore, this triangle you see here represents a right triangle, or right angle triangle. So I'm going to cut it out here. Now we are going to identify another type of triangle. This one is called an obtuse angle triangle. It's called an obtuse angle triangle because one of the angles will measure more than 90 degrees. In this case, this angle here measures 117 degrees. Therefore, this triangle is an example of an obtuse angle triangle. So once again, I'm going to cut out the obtuse angle triangle. Okay. Now we go to the third type of triangle, which is called an acute angle triangle. In this case, all of the angles in the acute angle triangle measure less than 90 degrees. So, if you look here, this angle measures 59 degrees, which is less than 90 degrees. This one measures 79 degrees, also less than 90 degrees. And the third angle between the line segments measure 42 degrees. So this is an example of an acute angle triangle. So I'll take my scissors once again, and I will cut out this triangle. Okay, so now I have my three triangles. The first one I showed you was the right angle triangle. The second one I did was the obtuse angle triangle. And the third one was the acute angle triangle. So I'll take the labels and put them beside each of the triangles so that you can see for yourself which triangle is which. So this represents the right angle triangle. It's the obtuse angle triangle. And the third and final triangle is the acute angle triangle. Okay. So there we have it. The three types of triangle. The right angle triangle, where one angle measures 90 degrees. The obtuse angle triangle, where one angle measures greater than 90 degrees. And the acute angle triangle, where none of the angles measure greater than 90 degrees. Okay. The exercise we're going to do has to do with what are called least common multiples. So you look at the sequence of numbers here. You have multiples of 3, multiples of 2. So we're going to look for the least common multiple in both the numbers, sequence of numbers here for 3, and multiples of 2. We notice in the sequence of numbers for 3, we have 6 that is common to both multiples of 3 and multiples of 2. Therefore, the least common multiple for these two sequence of numbers is 6. Let's try multiples of 5. You see what we have. We have 5, 10, 15, 20, 25. For 3, we have 3, 6, 9, 12, 15. So we have 15 common to both multiples of 3 and multiples of 5. Therefore, the least common multiple for these two numbers would be 15. So we have a match here. Let's put it away. And let's try something else. Let's try multiples of 10. see if there's any common sequence. Okay, so notice I have to be careful in aligning all the multiples under the counters which are above 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 5 we have 10, 15, 20, 25, 30. For 10 we have 10, 20, 30, 40, 50. So right away, the least common multiple for both these multiples of 5 and 10 would be 10. Therefore, the least common multiple for these two sequence of numbers would be 10. All right. So this is an exercise in showing how to find your least common multiple between a sequence of numbers.